Alrighty, we're ready to start Unit 3 now, and this is probably one of my personal favorites to teach. Um, I just like the stuff that goes on in it. I think it's interesting, and I'm a math nerd, so to me this is fun. Um, but today we're talking about properties of parallel lines. So remember, uh, in Unit 1 we defined parallel lines as two coplanar lines that never intersect. Okay, so we're looking inside one plane, and we're going to see what happens when two parallel lines are crossed by another line. We'll get some interesting relationships. But first, we need to talk about a transversal line, what it is. So we define that to be a line intersecting two coplanar lines. And I want to make a note here. These lines don't have to be parallel to be called for this to be called a transversal. Um, any two lines that are crossed by another line, this line that's doing the crossing we call the transversal. So it's a line intersecting two coplanar lines at two distinct points. Okay, so we've got two lines here. They're obviously not that parallel because they'll eventually intersect. This line right here, this big diagonal line, this is the transversal because it is intersecting the two lines at this point and this point. And because of that, we have, in this instance, we have 8 different angles that happen. Okay? And however these angles are positioned to each other is where these names come into play. Okay, this one you already know about, so this shouldn't be new. But these might be new. Um, you may have talked about them a little bit in middle school. I'm not sure, but so I'm going to use this picture up here to help us define what these are, and then we'll say some examples for all of these. Okay. So corresponding angles are the first type we're going to talk about, and we kind of can define these as angles that are in matching corners. But that sounds kind of strange, but what I mean by that is, for example, let's look at angle 1 right here. I like to tell myself that there's a top area that to look at and then a bottom area to look at. Okay? Angle 1 I would say is being in the upper right corner of this top neighborhood. Okay? If you think of all 4 of these angles as being the top neighborhood, angle 1 is in the upper right corner. Well, who is the upper right corner down the lower neighborhood? Well, that would be 3 because it's an upper right. So we say that angle 1 and angle 3 are an example of corresponding. They're in the same location, but in different areas. And by location, I'm talking about that corners thing. Another example, if you reference from angle 2 is in the upper left. So upper left would be 7. So 2 and angle 7. The other pair would be 5 and 4. That's your lower left. And then 8 and 6 are your lower rights. So that's all 4 pairs of correspondings. Okay? Alternate interior angles. So there's 2 parts of the definition. There's the alternate part and the interior part. So alternate refers to that these are on opposite sides of your transversal line. So they have to be on different sides of this transversal, okay? The interior part refers to that they are going to be inside the area between the two coplanar lines, okay? So you can kind of think about, I'm going to shade it real quick, but I'll erase it. This would be the interior, okay? And then obviously everything outside of that would be the exterior. So let me erase that because I don't want to leave that there. Okay, so these are going to be inside the two lines. So we need to find a pair that is inside the two lines and on different sides of this transversal. So I noticed that 5 and 3 fit that definition. They're both on the inside of the angles and they're on different sides. So angle, oops, that's a terrible angle sign. Angle 5 and angle 3. And then the other pair would be 8 and 7. Okay. Alternate exterior. So these are still opposite. Opposite sides of the transversal. But now they're outside the two lines. So we still need to be on different sides of the transversal, but now we need to be outside this middle area. We've got to be on the outsides. So I noticed that if you look at angle 2, go to the opposite side and then go look down. That would be angle 6. And then from angle 1, opposite exterior would be angle 4. So angle 1 and angle 4. Okay. Now we've got same side interior. So now it's on the same side. Oops, I don't know why I put a hyphen there. The same side of the transversal. And we're still inside the two lines. So now go back to the interior space and find two angles that are on the same side of your transversal. So one pair would be 5 and 7. The other pair is 8 and 3. Because those are inside the two lines and they're on the same side of the transversal. And then same side exterior. Oops. Same side of transversal. And these are outside. The two lines. So we got to be on the same side, but now we got to be outside in the exterior area. So angle 2 and 7, or no, sorry, not 7, 4. And then 1 and 6. Okay, those are the newer names, and they're kind of like their definitions. And you're going to have to know these because you could be asked a question, are these two angles such and such? Are they corresponding? And you have to remember what that relationship means and look at the picture to figure that out. Vertical angles we just talked about. These are angles across from each other. Okay, sometimes these will come up again. Remember, you're looking for an X shape. And so there's multiple examples here. I'm just going to pick two out. Angle 2 and angle 8 are vertical because they're across. Another pair would be angle 3 and angle 4. There's a lot more you could put there. I'm just going to put those for now because you should know what vertical angles are by now. Alrighty. Now, so when we first looked at this, we just said two lines in general. We don't know anything special about them. But when these two lines are parallel, there's a lot of interesting relationships that happen. That's what I'm getting ready to show you. Oops. Okay. So, these two lines are parallel, and it's not marked on here right now, but I do want you to add the markings to say that these are parallel. And those markings are, you put these little filled in arrows. Okay? So that is your clue that those two lines are parallel. Those number of arrows could vary depending on how many lines you have in your figure. It's the number of those arrows that count as to who's parallel to who. Okay. Now, so I've these are actually like all different kinds of theorems, but I've just kind of like condensed them. So the theorem says if two parallel lines are cut by a transversal, then all these things are going to happen. And so let's first look at corresponding. So if two parallel lines are cut by a transversal, then corresponding angles are congruent. Remember, congruent means exactly the same. And so let's identify our pairs of corresponding angles, and then we can say who's congruent to who. So if we start here at 1, 1 is in the upper left corner. And so if we come down to the bottom neighborhood, upper left would be 5. Because these are parallel, we can say that angle 1 and angle 5 are congruent. So we'll say angle 1 is congruent to angle 5. And let's keep going. So if I start at 3, 3 is in the bottom left. 7 is also the bottom left, so those two are congruent. If we reference from 2, 2 is the upper right in the lower neighborhood. 6 is the upper right, so 2 and 6 are congruent. And then finally, angle 4 is congruent to angle 8. Okay, that's all your pairs of correspondings. And because we've got parallel lines, each pair is congruent. Okay? Next theorem. If two parallel lines are cut by a transversal, then alternate interior angles are also congruent. So let's find our alternate interiors. So remember, alternate interior is on opposite sides of your transversal line. So the transversal is this one doing the splitting. And then interior means they got to be inside your parallel lines. This time you got to look inside your parallel lines. So 3, 4, 5, and 6 are those that are inside. And of those 4, 3 and 6 are opposite. So angle 3 is congruent to angle 6. That's a pair of alternate interiors. And the other pair you should be able to see is angle 4 and angle 5. Okay? Same side interior angles. So now we're still inside the two parallel lines, but now we look on the same side of the transversal. These are no longer congruent. These are actually supplementary. What does supplementary mean? Hopefully you remember. It means that they add up to 180 degrees. So who's same side interior? Well, that looks like it's 3 and 5. So angle 3 plus angle 5 is supposed to equal 180. And then the other pair, angle 4 plus angle 6 equals 180. Okay. Now we're going to go to alternate exterior angles. So if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So now we look outside the two parallel lines for the exterior part, and then for alternate, we need to be on different sides of the transversal line. Okay? So let's find a pair. If I start with angle 1, that's on the outside. Who is outside but opposite him? That would be angle 8. So angle 1 is congruent to angle 8. And then angle 2 is congruent to angle 7. And then the last one, if two parallel lines are cut by a transversal, then your same side exterior angles are supplementary. And so we're still outside, but now we will be on the same side. So this would be angle 1 plus angle 7 equals 180. And then angle 1, or not 1, I just used it. What am I doing? Angle 2 plus angle 8 equals 180. Now, I want to take a moment here and mention that there's not all these are the only theorems, the 5 theorems. You'll have to excuse me. I just had a massive brain fart. I was trying to say something, it just didn't come out of my mouth properly. Notice that the only theorem that was not used was something about vertical angles. Okay, that's not enough. That's not special enough to be counted in its own theorem by this. The vertical angles that we mentioned on the front always happen when you have lines crossed by transversal. So they're not special enough to get their own theorem, unfortunately. And when we talk about Tuesday's lesson, I'll bring it up again as to why it's not special enough. Okay, we'll save it for Tuesday. All right, now we have everything we need to start solving some problems. So the big idea is here was 1, you have to know what the relationships are, and 2, by that I mean what corresponding means, what alternate interior means, all those names. Then you have to know their specific relationships, which is what these are. So notice that corresponding and both alternates are congruent. The same sides are supplementary. And I tell myself, put the S's together. The S's being same side goes with supplementary. The other ones are always congruent. That's an easy way to remember it. Okay. List all angles that are congruent to angle 2. So let's mark where angle 2 is at. I want to know everybody that's congruent to angle 2. Well, angle 2 is in the upper right corner of this top neighborhood. And if I look down below, angle 6 is in the top. Sorry, brain fart again. Upper right corner. And so those are congruent. So angle 6 is an option. Angle 2 is on the exterior of the parallel lines. I forgot to put the parallel things here for you, so you might want to go ahead and add them. So angle 2 is on the exterior, and who's opposite on the exterior? That would be 7. So angle 7 is an option. And there's one more. It's angle 3. And you can say that for a variety of reasons. You could say that 7 and 3 are congruent because they're corresponding. And then because we proved that 2 and 7 are congruent using the transitive property, look at that, me pulling stuff from the old unit. By the transitive property, 3 has to be congruent to 2. Or angle 2 and 3 are vertical, and we know the vertical angles are also congruent. So that's one reason. We could also have said on angle 7 here that angles 6 and 7 are congruent because they're vertical angles. And because 6 and 2 are congruent, then by the transitive property, 2 and 7 are congruent. The idea on this kind of problem, guys, is that there's multiple reasons to say why these are congruent. As long as you know what those reasons are, you can just list out who's congruent to who. You don't have to justify for me. Although you might on your homework, so it's probably good to know why. I just, if you need to hear those explanations, just rewind the video a little bit to hear why. But so there's a multitude of these relationships here that we could use here. Now, this is one of the problems I like. I give you one angle measure. I'm telling you, angle 1 is 113 degrees. I want you to tell me all the others. So the measure of angle 2 equals the measure of angle 3 equals the measure of 4. Okay. So I think let's start with all the ones that would be congruent to angle 1. So angle 1 is right here. That is the upper left. And so in the lower neighborhood, upper left would be 5. That means 1 and 5 are corresponding, which means that they must have the same angle measure. So we know that angle 5 is 113 degrees. Five and 8 are vertical angles, and because we know 5, we can say that angle 8 is 113 degrees. We could also say this because angles 1 and 8 are alternate exterior angles, and we know they're congruent. And so 8 would have to be 113 degrees. Now that we know that 8 is 113, we can say that 4 is 113 because 8 and 4 are corresponding. They're both in the lower right corner. Also, 1 and 4 are vertical, so you could say that because of vertical angles. Now, how do we find the rest of them? Well, here's the easiest thing I know how. easiest way I know how to do it. Notice that angles 1 and 2 are a linear pair. Remember, a linear pair means two adjacent angles such that they can add up to 180 degrees. So they're supplementary. So we can do 180 minus 113. That means that angle 2 is 67 degrees. And then we can fill the rest of them in. 2 and 3 are vertical, so they have to be the same. 2 and 6 are corresponding, so that has to be the same. And then either by verticals with 6 and 7 or alternate exteriors with 2 and 7, angle 7 is also 67 degrees. I really like this problem, and I think there might be one on your homework that's related to this, and probably on your test also. If you know one of these angle measures, you can find all the other ones really quickly using these relationships. Okay. Now, this is like my favorite part. We get to determine the relationship that we see, set up the appropriate equation, and solve it. Okay? So let's figure out what relationship we have here. Sorry, testing the camera. So notice that both of these angles are inside the parallel lines, and they're on different sides of the transversal. Hopefully you see that. That means these are alternate interior angles. What do we know about alternate interior angles? They're congruent, and so these must be equal. So we set them equal to each other. And then we simply solve. All we have to do is subtract 70. Now you might be thinking, Mr. T, wait, that can't be right. We can't get a negative answer. Look at what we're doing now. We are solving for a variable, not the actual angle measure. Our variables can and sometimes will be negatives. That's fine. The only thing that can't be negative is the specific angle measure. Okay, that can't be negative. But the value for your variables can. Okay. Second problem. Determine the relationship first. So these are inside the parallel lines, right? But they're on the same side now. So this is a same side problem, a same side interior problem. And what do we know about same sides? They are supplementary, meaning they add up to 180 degrees. So we'll add the two angles up. X plus 62 plus 126 plus x equals 180. Now we need to combine like terms. X plus x is 2x. 62 and 126 adds up to 188. That equals 180. Now we'll subtract 188. We get negative 8. X equals negative 4. Okay, on the last two, we still have to solve for x, but then I want us to go back and find the specific angle measure of the angle that has the x in it. Okay, so basically when you find x, go substitute it back in. You'll be asked to do this on your homework, so I wanted to do it on your notes here. So what relationship do we have? We're inside opposite sides, so these are alternate interiors. and those have to be congruent. So 7x plus 8 equals 50. They have to be the same thing. So solve, subtract 8. 7x equals 42, divide our 7. X is 6. So that's part of the answer. And now I have to go plug x back in here. And I should get 50 because remember they're supposed to be the same thing. So hopefully I did this right. 7 times 6 plus 8 equals, that's 42 plus 8, yeah, it's 50 degrees. So obviously if your angle measures don't match, well, let me rephrase that. On the problems where the angles are supposed to be congruent, if they're not matching, that means you've probably done something wrong. Okay? Let's look at this problem. Notice the relationship. Let's see if we can figure it out. I have one angle on the inside and one angle on the outside. That's kind of like your clue that this is a corresponding problem. A lot of kids forget about corresponding for some reason. But notice that both of these angles are the lower left corner in their neighborhood. So those are corresponding angles. And they're also congruent. So we set 7x plus 13 equal to 8x plus 4. We'll subtract the smaller x to leave our x positive. Now we'll subtract 4. So we'll get 9 equals x. Now we need to plug it back in. So 7 times 9 plus 13 equals, that's 63 plus 13 is 76 degrees. 8 times 9 plus 4 is also 76 degrees. And this is a corresponding angle problem, so our angle measures right here were supposed to match. If they didn't, we know we did something wrong. All right, that's all I have. I know this video was a little bit long, but I wanted to make sure I explained everything thoroughly so that I hope that you can do the homework successfully. The homework is going to be digital. It's a Google form. I think it's 24 points, so maybe like 12 problems, I think. And there's a variety of things you have to do. You might have to pick all the angles congruent to a specific angle. You might have to justify why angles are congruent, and you may have to solve equations and plug x back in. There's a lot of things to do in that. Please be sure to watch this video in its entirety before you do homework, and as always, if you need help, let me know.